Alright, in this video we're going to take a look at the solution of this differential equation. dy dx is equal to e to the x plus y. Also, we're going to find the domain of the solution if y of 0 is equal to y naught. Okay, so this one is a separable differential equation. We can write the right-hand side as e to the x times e to the y. And so we get e to the minus y dy is equal to e to the x dx. Now, I get that by dividing. Now, I'm not going to divide by 0 here because e to the y is never equal to 0, so I don't have to worry about some extra solutions that might be constants. All right, we integrate these. On the left-hand side, we get negative e to the minus y. On this side, I get e to the x plus c. And now I just have to solve for y. So let's multiply by the constant here. So e to the minus y is equal to negative e to the x plus c, because negative 1 times an arbitrary constant is an arbitrary constant. Then let's take the natural log of everything. So negative y is equal to natural log of c minus e to the x. And then finally, we'll multiply by negative 1, so y is equal to negative natural log of c minus e to the x. Okay, so that's the general solution. Here, the initial value is given to be y of 0 is equal to some number y naught. So if that's y of x, y of 0 is some initial number y naught is equal to negative natural log of c minus 1. So this allows me to solve for the constant c. Let's bring the minus sign back over. Negative y naught is equal to natural log c minus 1. Take e to both sides. E to the minus y naught is equal to c minus 1. So that c is equal to 1 plus e to the minus y naught. And so coming back up here, we get that y of x is equal to negative natural log of 1 plus e to the negative y naught minus e to the x as the solution of this initial value problem. So that's the solution. Let's figure out the domain. The domain of this, well, where do I get in trouble with natural log? I get in trouble when I have 0 or less in here. I'm okay as long as the thing inside the natural log is greater than 0. So 1 plus e to the minus y naught minus e to the x has to be greater than 0 for this to be defined. So that means 1 plus e to the minus y naught is greater than e to the x. And I'm allowed to take the natural log of both sides because natural log is an increasing function. And so there is my domain. So the domain is going to be from minus infinity to natural log of 1 plus e to the minus y naught. So there's my right endpoint, not counting the endpoint. My left endpoint goes all the way to minus infinity. So in this way, the domain of the solution very much depends on what this initial value of y naught is. But here's a solution, and the domain of the solution is given right here.